Hello and welcome to another video, this time on the Mechanics A2 2019 question 5, and this question is about projectiles again, so another one of these tricky projectiles questions. And straight away looking at this one, I think this is the one where you get a collision. Yeah, so these are quite interesting. They always used to have collisions. It was practically its own separate topic in the older M1 days, but or M2 days. Well, they used to have collisions in M1 and in M2. Anyway, let's have a look at how this one's going to work. Yeah. Now, I'm going to basically have two things going on here. Yeah. I've got P, which clearly has, and you can read all of this if you like, but really pretty much all of it is on the diagram, I think. We know they collide after 2 seconds, which is interesting. Until they collide, the balls are modelled as particles moving freely under gravity. Okay, fair enough. Find the velocity of P at the instant before it collides with Q. So we need the velocity of P at t equals 2, yeah, because it's the instant before it collides with Q. So, okay, let's write down what we've got for P. We've got U, and this is taking this A as the origin here, yeah? We've got U equals 20 cos 30, 20 sine 30, and that's just a habit you want to get into when you're doing these questions. Cos for the x, sine for the y, provided the angle it makes with the x-axis is there, because then, think about your triangle. The 20 is on the hypotenuse, so you've got 20 cos 30 there, 20 sine 30 there. It will always work like that. You want to practice lots of these questions to get used to that. A is going to be 0 minus g. Notice as well I'm using vectors. I know not all teachers do that, but I quite like doing it like that. I'm going to quickly simplify this as well, because I think cos 30 is root 3 over 2, so that's 10 root 3. And that's sine 30 is a half, so that's just 10. Okay, what else do I know? I know t equals 2, and I want to find v. Yeah? And so I'm going to use v equals u plus at. Yeah? Okay. V equals u plus at. Now, if you look at this, it seems natural to, you're going to need to work out the x component and the y component here. So why don't I just do this whole thing as a vector? Yeah, here's your u, 10 root 3, 10, plus a times 0 minus g, and then t is 2. Yeah, then I can just work it out as one single column vector. And so we're going to have 10 root 3 for our x component. And we're going to have 10 minus 2g for our y component. And so the velocity of P at the instant before it collides with Q is simply going to be, if I write them as decimals, and let's just quickly go to my calculator and write these down as decimals. 1 second, I'm just tapping it in. So 10 root 3, I think it's about 17. Let me just check though. Going back into the normal mode of my calculator, 1 second. 10 root 3 comes to 17.3. And then 10 minus 2g, well, that's 10 minus 19.6, which sounds like minus 9.6 to me. So I'm going to write it in there as minus 9.6. And there's your velocity, at least as a vector. Yeah. Now, these questions can sometimes be a little unclear, if you ask me, and sometimes you kind of feel like you're supposed to almost guess that about what they really want here, like in terms of how they want the answer given, because it doesn't feel like we've done 6 marks worth there, does it? Now, you can write the velocity as a vector, but I think they actually want you to state here the direction it's moving in and the speed, which I'm not particularly happy with, because I think they should phrase that question better if they want the speed and the direction, because I think it's a little unfair. But in the mark scheme, actually, they do, this is basically worth 3 marks. And then working out the speed and the direction is worth the last 3 marks, and it's true to say as well that if you give a speed and a direction, then you have given a vector quantity, if you see what I mean. But it just feels a little bit unfair not to make that absolutely clear at the start of the question. But anyway, let's do that. Speed, I think, just in terms of like how much work you've done there, you recognise, oh, they probably want me to do something else. The only other things we could do is work out the speed by using Pythagoras. So I'm just going to do that squared plus that squared square rooted. So answer squared plus, okay, 300, and then square root the answer. Okay, I'm getting 19.8 for that. That's from 17.3 squared plus minus 9.6 squared. You get 19.8 for the speed. And then the direction, well, if you think about this as going, basically the ball's going down at this point, isn't it? Yeah, it's going 17.3 across, 9.6 down. If we call that theta, then you can see that tan theta is going to be 9.6 over 17.3. And so inverse tan on that, inverse tan of 19.6 divided by 17.3. Oh, sorry, 19. Did I say that? Oh, I typed it in wrong. It's very easy to input things into calculator incorrectly, so watch out for that. I've done it a million times myself. Okay, I'm getting angle of 29 degrees. And always say which direction it is. It's below the horizontal. They often like you to say whether things are above or below the horizontal. Yeah, but I agree. I actually strongly believe that that question is ambiguous. Maybe the examiners would say, oh, no, 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 but look at how many marks you've done, and then think, oh, I've probably got to do a little bit more work for that one. Okay, B, find the size of angle theta and the size of angle U. Well, this tells me a lot about Q, because, firstly, I could find out the position. There's lots of things I could do here. I could find the position of P after 2 seconds now, yeah, using Suva again, and then take that away from 50 to find Q. So that's one way I could do this, probably the easiest way actually as well. So let's find the position of P first. That's what I'm going to do first here. So because then with those values, with the position vector that I get, I can easily reverse engineer it for Q, so I can find where Q is. So, well, I'll then know where Q is basically after 2 seconds because they're colliding, and then I can use that to find theta and U. Yeah. So, okay, let's find the position of P. We've still got U is 10 root 3 and 10. I think that was right for U, wasn't it? Let's have a look. 10 root 3 and 10. You've got A is 0 minus G. You've got T equals 2, and you're looking for S. Yeah, and S equals UT. So that's going to be 10 root 3, 10 times 2, plus a half AT squared. So times by 2 squared. And we can work it all out as a vector, can't we? We're going to get 20 root 3 on the top. And on the bottom, we're going to have 20 minus G over 2 times 4. So that's 20 minus 2G. Nope, not 10, but 20. So similar to answers what we got before, 20 minus 2G. 20, yeah, take away half G times 4, take away 2G. Cool. Okay, so that's our actual position. Yeah, and you can work out what that actually means. If you think about it, that means we're at, well, I'm going to leave the first one as 20 root 3, but I just want this one as a second one. Well, actually, it's this first one I need to write down as a decimal because I need to take it away from 50, just because the other one's going in the opposite direction. Then I can work with the other one with that way as my positive, if you see what I mean. And so let me just work out what 20 root 3 is. 20 root 3 is 34.64. And 20 minus 19.6 is going to be 0.4, I believe. Okay, cool. So I've got the exact position, now think of this as on a graph. We know we've gone 34.64 across from this origin here. And we're also 0.4 up in the air. Well, that means if I now treat this as the origin, which is probably the sensible way to do it, I now know exactly where Q is going to be. So if I keep that picture in the shot, for Q, we can say U equals, now if we take this way as positive, we can say U equals U cos theta, U sin theta, We can say A is 0 minus G. None of that changes. We can say, and now we can say T equals 2. Yeah, because we don't know this, but we also know exactly where it is S-wise, treating this as the origin. It's going to be 50 minus 34.64. And what is 50 minus 34.64? It is, of course, 15.36. And we've got 0.4 because it's going to be the same y component for both. It's just this issue that, you've got to think about it going in that direction. And so now we should be able to work out u and theta. Yeah, so let's do it. S equals a half t, S equals ut, sorry, plus a half a t squared. So we've got that equals u cos theta, u sine theta times 2. Plus a half times by a times by t squared, which is 4. So that's going to be times by 2. And so we can now come up with two equations. Let's take the first one, which has a 0 in it. 15.36 equals 2u cos theta. Yeah, that's still got two unknowns, so that's no good for me yet. But 0.4 equals 2u sine theta minus 2g. Yeah, and so what I can do now is I can use the principle of substitution. If I call u 15.36 over 2 cos theta, then I can plug that in there and I've got rid of my u's, or I could get rid of the cos theta, but this seems like a sensible enough way of doing it. So I get 2.4. Actually, it's probably better I use 2u because 2u is just 15.36 over cos theta. I'm timesing that by sine theta, which is lovely because it becomes tan theta. And so we get 15.36 tan theta, and that equals 0.4 plus 2g. Well, that's 0.4 plus 19.6, so that's actually 20. And so tan theta equals 20 over 15.36, and theta equals inverse tan of that. There may be quicker ways to do this. Seeing 20 pop up again there makes me think there's probably an easier way of doing that, but it's probably not going to be that much easier. It's going to be a similar kind of question. Inverse tan of 20 divided by 15.36, and you get 52.5 degrees for that. And then for u, well, if we just plug this back in, for u is going to be that over 2 cos theta, isn't it? And so we just need to do 15.36 divided by 2 times cos of 52.5, and that will just give us our answer for u. And I think it comes to 12.6, but let me just check it. 15.36 divided by 2 cos 52.5. Okay, 12.6 meters per second. And there we go. That's most of the question done. State one limitation of the model other than air resistance. Damn, they've got us on the can't use air resistance easiness. Well, the objects were treated as particles, so we've ignored the dimensions of the objects. As we treated them as particles, that's probably the easiest answer. But you could have many others. You've ignored the spin. There's, it does not take into account the fact that there could be wind involved and stuff like that. But I've ignored the dimensions of the particles. Of course, if they had dimensions, then they won't be meeting exactly at t equals 2. It'll be slightly before that because they've all got width. Anyway, hope that's helpful and useful for you, and keep up the hard work. Bye bye.